Hello, everyone. Welcome back. First off, apologize for the mix-up here. I know there was an inconsistency between the Hoover app and when the session was scheduled on our schedule. So apologies for that. I know a number of people were waiting and were asking questions. But we are now ready to get going here. So let's jump into it. Welcome back from lunch. If you were just eating lunch. Want to mention that there is a poll question for this session. I would encourage folks to respond to it. I did check the responses a few minutes ago. It looks like about 70 to 75% of folks have not deployed Cognos on a public cloud provider. So some have, but most have not here. So good to have that context. I think there's a lot to be learned here. There is a session giveaway. One attendee in this session will be randomly selected to receive a Google Nest Wi-Fi Mesh router and point, valued at $270. Very cool, I could use that. Everyone gets one entry also for the IBM Grand Prize, which is a 14-piece travel collection valued at over $1,000. And you can see all the giveaways on the app homepage. I'm now going to introduce Chris Chapman, who'll be presenting this session. Chris Chapman is an AWS solutions architect for PMsquare. Chris has worked with Cognos for 8 years, and during that time, he has helped clients design and implement Cognos by pushing them to think outside their typical thought processes. When not working to help clients, he's usually wrangling his 2 kids and hoping the Chicago Bulls get some help this season. Chris will be discussing the unique needs of a Cognos cloud deployment and new approaches and architectures that should be considered when running Cognos workloads on AWS. So I'm now going to turn it over to Chris.
Welcome everyone to Bacon 2021. This session, we're going to be looking at an introduction to architecting Cognos on AWS. I'm Chris Chapman, and I'm an AWS solution architect here at PMsquare. So for the agenda for today, it's really going to be broken down into 2 key areas. The first is going to be how to think about migrating Cognos to AWS. And for that, to help frame it, we're going to look at what AWS is defined as their 6 R's of migration strategies. It's a collection of migration types that they've seen their clients leverage. And we're going to talk through and see where Cognos migrations typically will fit within that range. And then we'll also look at what was both familiar and unfamiliar about running Cognos workloads on AWS. And that will lead us then into the unfamiliar, which will be the tools and techniques that you can use on AWS that have been previously unavailable to you if you're running this workload in an on-prem data center. Now, it's important to note here, so we see the 3 outlined that was discussed today, which are the application load balancer, or ALB, multi-AZ architectures, and EC2 instance types and sizing. But this is not the full scope of how you can architect on AWS for Cognos. There are a number of tools and services that you can use to help enhance the reliability, availability, and maintainability of your Cognos environment. These are just good starting points. I would say if you're just starting your cloud journey, or if you're thinking about it, I would look at, focus on these 3 areas first. I think this will give anyone that's just starting out a good foundation to grow and expand from here, versus having to wedge these in after the fact if you've already deployed. But even if you have already deployed, the great thing about the cloud, resources can be created and stored quite easily. So you can look to adopt some of these architectures as well. So first, the 6 R's. So again, this is strategies that AWS has defined. They typically see their clients take from getting workloads from on-prem to AWS. For Cognos, really only the first 3 are in play. Things like repurchase, retire, retain, those are out of scope. With repurchase, we'd be looking at purchasing new license types. Probably not going to be the case. Retire, well, we're not retiring Cognos, we're keeping it. It's not going to go anywhere. So that's out of scope. Retain, that would be if we weren't really sure what to do, so we're just going to keep it as is and not look to move right now, which isn't the case either. We're definitely, in this instance, we will be looking to migrate it. It leaves us with the first three, which are a rehost, replatform, and refactor. So for a rehost, this can be thought of as just a simple lift and shift. Whatever your existing architecture is on-prem, lift and shift it straight to the cloud. Run on EC2, no other changes. It's the simplest, most straightforward path you can take. Now, if you're in a situation that you have a very tight timeline, IT, your business is saying, we need to deploy, we have an expiring contract with our current data center, and we have a really tight turnaround on that, or if you're just unsure where to really start, you'd like to adopt some cloud native services and tools to make your life easier, but you don't know really where to start. You're not sure, you haven't had a lot of hands-on experience. Rehost can be a great way to just get off the ground. It can get you in the cloud. From there, you can take your time, learn about the different tooling that is available, and looking at how you can attach and layer that on to that Cognos deployment. For those that are a little more adventurous, we have replatform. That's a bit of a step up from rehost. It can be thought of as lift, tinker, and shift. So you're, on the edges, you're going to be tinkering with the architecture, but overall the architecture is going to remain the same. Replatform example could be around database technology. So for the content store and audit database, typically you would have run that on a server, and if you were to just do a lift and shift, you would be running your Oracle or SQL Server database on EC2. Instead of running on EC2, you could look to replatform it and move it to something like RDS, the relational database service. We'll talk a little bit more about that later on in the presentation, but just a little preview. RDS is a managed service from AWS, allows you to run relational databases. Managed service in the sense that all of the administrative tasks, security patching, upgrades, infrastructure management is all managed by AWS. You simply run the database. But if you were to, during your migration, move your database workloads, specifically for context for audit database, to RDS, it'd be considered a replatform. Again, just tweaking some of the core technologies on the fringes, but ultimately the architecture is going to be the same. And then refactor. Refactor would be a reimagining of the application, the workload. Taking something like a monolithic legacy application, rebuilding it in a microservices architecture, run on containers or AWS Lambda. That, the full extent of that kind of a migration isn't available to us with Cognos. We have to deploy Cognos in the way that IBM is provided. So we are limited in how far we can go with that. But why I like to include it is I like to think that a fully realized migration would live somewhere in the middle between replatform and re-architect or refactor. Like I said, we're obviously not going to be able to rebuild Cognos, but there are a lot of different tools and services. I mentioned before that, I think that can be wrapped around or layered on top of that familiar Cognos architecture to enhance the experience of maintaining it, to improve the reliability of the environment. And by layering those on, so we won't get to that full refactor, but we somewhere in between replatform and refactor. So you mentioned that familiar. So that familiar architecture, you can see it on the right, probably familiar to many out there. When you deploy Cognos on AWS, a lot of this will stay the same. You're still going to have content managers and dispatchers and gateways. Those don't go anywhere. We mentioned the content store and audit database already, still will be there. Best practices around component redundancy, how to manage and store logs, outputting, report archive, all those best practices, all those best practice questions that you'll have to answer still will exist. And you can address them in a classical way that you've addressed them for years, or you can look at cloud native services that can help you address those in new and interesting ways. And what that leads us to is the unfamiliar. These are some of the tools that we can use to address those common best practice questions, and like I said, in different ways. So the three mentioned already we're going to be looking at is the ALB, multi-AZ, and EC2 instance types. There are a number of others out there. And it's really important to, I would say, as you make your, start your cloud journey or continue down your cloud journey, to really look at the different tools that are out there. Tools that you may not think may be applicable to integrating within your Cognos environment in one way or another, may actually have some use case. You'd be sort of, even something like a DynamoDB or Lambda. These are really open-ended services that have a lot of utility and a little bit of creativity. You may be able to incorporate them and make your life easier and make your management of Cognos just that much simpler. So to get started, we're going to look at the ALB. So first, ALB is like any other load balancer. What it does is it will route traffic to resources on the back end. In this case, and most typically within Cognos, that means a gateway or a number of Cognos gateways. And that's the typical use case I've seen with on-prem deployments. A number of clients that run an F5 load balancer, for example, because they want redundancy for the gateway tier. They want multiple gateways. In case one fails, they'll always have another one to fail over to, and that's kind of an architecture would facilitate that. And that use case still applies to running an ALB in AWS. You will have the ability to have gateway failover, which is critical and important, and something obviously should be considered. But you also have a number of other benefits from doing it as well. Fixed configuration point for DNS. For any company out there that may have a workflow where you will always have a net new set of servers that you're installing Cognos on, you've always hit the point where you get to the gateway tier, immediately need to reach out to the DevOps team that's responsible for DNS, have them repoint DNS entries to your new gateways. It's not hard, but it's another step in the process, another just configuration hurdle, another team you have to loop in, have to troubleshoot if it doesn't work. If you're doing upgrades on the weekend, now you have to have them available as well. It's a process. It can be a hassle to orchestrate. This allows you to do it. Configure it once. You don't need to reconfigure that DNS again. The DNS will point to the ALB, and down on the back end, you'll have your gateways where you can swap those in and out. But the DNS won't have to change because that ALB will be a fixed resource there. And that leads us into the simplified upgrades and maintenance. What this kind of an architecture also allows you to do is, because those backend resources can be swapped out freely and you're not going to be messing with DNS, you can change a lot of your processes around those upgrades. And hopefully, what I would hope for is that upgrade process will be simpler, more streamlined, and allow you to do it more frequently. Upgrades are the lack of upgrades or the lack of frequent upgrades that I see in most clients. It's just a hassle to go through the testing and the install, and the validation, and the retesting, and the revalidation, the reinstall. For every environment, every time, it can be quite a bit. And this will hopefully allow you to do is be much more simply, and we'll look at some examples of this with some architectural diagrams of how you can achieve this. But essentially what you can do is, because the ALB is simply routing traffic to backend resources and gateways, you can stand up a new environment. When it's time to cut over, you just point the ALB to that new Cognos environment. You're off and running. This should hopefully allow for better cutover windows. I know myself, having done a number of upgrades over my life with Cognos, typically it's a Friday night or Saturday night. Most of you probably experienced something as well. We'd all like to be doing something different with our weekend than upgrading Cognos, but that's the time it has to be done because obviously no one's in the system at that point. And if all goes well, what, an hour, 2 hours? But I've definitely had issues where it hasn't gone well. And there's been, been up to 2 or 3 in the morning, something went wrong, and it took a lot of troubleshooting and investigation just to figure out the source, and then obviously the remediation and fix to get it working. This would allow you to avoid all that. if something does go wrong, you can take it during normal hours, and when it's time to cut over, it's just that reconfiguration of the ALB to point to the new environment. Another key benefit here is improved security posture. Number of clients I know, they have a gateway outside of the DMZ because external users need access to that, whether it's either clients of theirs that they're sharing reports with, or a mobile sales force where they're out on site with their clients, and that sales team needs access to client data and reports as they're meeting with those clients. What this can allow you to do is still maintain that functionality, but now you don't have to have any servers exposed to the open internet. You can have even the gateway components on private subnets, being private instances, having no direct access to the internet, and only the ALB would be exposed. Traffic can still be routed to those private instances over the Amazon network and into those private gateways. And the only thing you're exposing is the ALB. You can further enhance this by wrapping the ALB in something like the web application firewall. You can go further at the network level and set up very strict NACL rules, security groups. This is just to show there is much more you can do around the security piece once you have implemented the ALB to further enhance that security posture. But just the mere fact of putting all of your resources on private subnets and private network is going to be a huge benefit from being able to run that ALB. So that may all sound great. You'd be interested, but how is the best way to, how should an ALB deploy? What's the best way? Well, a couple different ways. Obviously, you can do a single ALB per environment, one for prod, dev, QA. I would definitely recommend an isolated single ALB for prod. We want to make sure all our production resources are as isolated as possible. Don't want any disruption there with cross-contamination. But for lower environments, especially lower environments that have less traffic, less workload, a shared ALB model would be recommended, and it's one I would typically recommend. In this case, one ALB can service multiple environments. This does a number of things. It further simplifies your administration configuration, just one resource that can service many. Then also, you have cost reduction. ALBs are not free. They do cost money to run and operate. It's a combination of hours run and also traffic that passes over them. But this allows you to consolidate that as well. You're not going to have to pay for multiple. You can just pay for one. So furthering that benefit of the cloud and reducing cost of your IT infrastructure. So we said it's easy to talk about these things, but I think seeing is believing. So we have some example architectures that'll hopefully help illustrate what some of these workflows can look like. So first, just to start out, just at the core of how the ALB will work, just the level set. Like I said, this is going to look very similar to any load balancer you've seen thus far. Users will hit the load balancer first. It'll be assigned just via round robin routing. Now this can be split if you would prefer to split 60/40, 70/30. You can modify that split. By default, it's round robin. It'll make sense to leave it that way unless there's a compelling reason to tweak it. So the ALB will route the traffic to one of two gateways. Those gateways will then interact with the dispatchers on the backend. And from there, the request will flow through to the content managers and data stores accordingly. Now for the shared ALB model, this would be an example of that. So you have your one load balancer sitting in front of, in this case, 3 different Cognos environments. And load balancers can route traffic to resources a number of ways. One of those ways is through simply path-based routing. So you can take advantage of this by, during your Cognos installation, giving your Cognos alias an environment-specific name. In this case, we didn't do anything too creative, just we have /sandbox, /dev, and /QA. As the user enters that URL and enters the appropriate alias, the ALB will route that request to the appropriate environment. And so this is a very simple pattern, very easy pattern to set up and configure. But you can see here that this would allow you, that simple configuration allow you to have one ALB manage or be able to service multiple environments. And this has the added benefit of, as you continue to develop and have new requests, often, let's say 11.3 comes out, and I've seen this before at environments, had, or at different clients, a new environment comes out, well, maybe they don't even want to touch Sandbox because some team is doing something special in Sandbox right now. We can't touch that, but we really need to test out 11.3. We need to stand up a new environment. And oftentimes they say, well, we're just not going to mess with SSL or DNS or anything. We'll just hit the dispatcher directly. In this case, you could stand it up and just attach it to the load balancer, assign it an alias of 11-3. Traffic can be routed there. More users could access it. It'll be more accessible versus having to mess around with just hitting the dispatcher URL directly. Now the upgrades. So this is one I get most excited about. Like I said, being up to 2 and 3 a.m. sometimes when upgrades go wrong. I'm always looking for ways to avoid that and simplify it. And I think the ALB is really key here in that. So we'll look at this example. We have 11.1.7 running. We want to go to 11.2. A new way to think about the upgrades, and mentioned before, typical upgrade process, right, would be, so we start in Sandbox, we upgrade Sandbox. Then we move to dev, we import content again from prod, sync it, we upgrade, we do testing, then we move to QA, we import, we test, we remediate, we fix, do more testing, and we finally move to prod, and we, that weekend upgrade where we have to install again and import and test again. But with this, what we can do is, we simply bring up net new Cognos environment, brand new instances, fresh instances, install the software. From there, we can perform our testing. We can import the content, we can do our testing, developers can test, and users can test. Once we're satisfied that that content is set and that the environment is sound, for the cutover, we simply repoint that ALB to the new environment. We're off and running. We don't have to go through that lengthy, reinstalling Cognos, testing and validation, late nights, making sure it's working. It's being done right at the end of the day. Do the cutover, test, make sure that the environment is accessible, reports are still running okay. Now we're off and running. Now, if there is a showstopper that's found, you can also just bounce right back. Same kind of configuration, just repoint the ALB to the old environment, and we're back to 11.1.7. This is good for a number of reasons. Obviously, the cutover time, just being able to a minor configuration change to the ALB and cutting over, is a huge time saver. But starting with a net new instance is also important. I think for anyone that's been working with Cognos servers for a while, most of the time, and what we see is there's a set of servers, and that is what Cognos gets installed on, whether it's over-the-top installs or parallel directories. Those are the servers, and they stay up and running for years and years. And it's often, as over time, I think the technical term is those servers get weird. There's weird performance hiccups with them. Applications start maybe running weird. You get odd error messages. Just the server runs for an extended period of time. I think it's going to just get a little funny with it. It's not you get a clean slate every time. So you can avoid any of those, that technical term, that weirdness. Always be on a clean slate. Always make sure that Cognos will run its most optimal way with that clean slate and fresh install every single time. And then once you're confident that the new version is sound, the new environment is sound, users are using it with no issue, blow away the old environment. No need to keep that running, you need to maintain it, just terminate it, get rid of it. We mentioned before, these are not fixed resources. It's not like an on-prem deployment. It's this bit of a hurdle, I think, a lot of Cognos administrators to get over is Because like I said, a lot of those times those servers are there and fixed for years and years and years. Don't need to do that anymore, and really try to get out of the business of doing that as much as possible. When you're done with it, simply delete it, move on. So that goes over some of the key reasons of why you'd want to deploy with an ALB, some of the benefits and different ways you can deploy the ALB with Cognos. Now we're going to look and move over to multi-AZ. So multi-AZ, obviously, well, what's an AZ? Well, an AZ is Amazon lingo for an availability zone. An availability zone is simply a data center or one or more data centers in a particular region. And multi-AZ, or the multi-AZ concept, is deploying your application resources in more than one AZ. So why would you want to do that? Well, because even some of the biggest cloud companies, internet companies can have failures. Linked in the notes for this talk, there's an article from The Verge from late last year, I think in November, where I think like half the internet just going dark. Websites like Warby Parker and Reddit were down because AWS had an outage. The entire region went down. There was an issue on their end. I think they had an issue with their Kinesis service, and it ended up taking down an entire region. So it can happen. It's easy to think that like Amazon.com and AWS, they're just always on. They're designed to be very resilient, but they can have issues too. So it's recommended always deploy in a multi-AZ architecture so that your application will be available and highly resilient to any kind of outages that may happen. So how this relates to Cognos? Well, when you think about deploying Cognos in multi-AZ, what essentially is you're doing is you're running a parallel DR environment. Most often when we engage with clients and we talk about DR, it's an afterthought. Yeah, we've got servers in this other data center that may or may not even have Cognos installed on them. Oftentimes they don't, sometimes they do. If they do, it's probably not the most recent version that's in prod, because it's an extra chore. It's that extra hassle of that upgrade cycle, right? You have to go and install it again and install this environment that's probably never going to get used. So what multi-AZ will allow you to do is, in your base architecture, you're running a parallel environment in a separate data center. You have one data center failure, you'll automatically fail over to another. That enhanced failover is so critical. We're going to do an example of what that'll look like. The failover can happen within minutes. You can go from data center outage to backup and running in just a few minutes with no human interaction, which is critical. You think about what that would look like today if on-prem. If your data center goes out, you migrate over. You have to move your content store backups, import those, sync those, possibly install Cognos, or at least bring it up, test to make sure that everything is actually working, repoint DNS. All with the multi-AZ architecture, all that stuff, all those steps are done on the fly. A lot of the heavy lifting is done by some of the managed services like RDS we mentioned before. That managed service has a feature that you can deploy in a multi-AZ configuration, which means that you can define more than one AZ for RDS to be deployed. You'll still have a primary AZ, but then in the extra availability zones, you'll have read replicas that are synchronized in real time. And should the primary fail, just simply fail over via DNS failover to one of the read replicas. So let's take a look at what this would look like to fail over. So what we're going to do is we're going to bring down a Cognos environment. We'll just half of it. And then we're going to go through some more architecture examples, and we'll come back to it in a couple of minutes. So here we have Cognos. I'll get logged in. All right, so here We're logged in. We've got our samples, everyone's favorite sample content, and that over there. And then this environment is hosted on these EC2 instances. You can see, so we're on 11.1.7. We have 2 content managers, 2 dispatchers, and 2 gateways. If we bring up one of the content managers, we can go down to the networking details, and we can see this resource is deployed in AZ1A, US East 1, and here we're 1B. Same with all of them, 1A, 1B. Simple, just 2AZ architecture. But if we want to simulate losing an availability zone, we will select all of these instances that are tagged with the -1, so everything in 1A, and we are going to stop those. Those are all offline. So those are shutting down. Now, Cognos is going to get through some funny stuff. Yeah, see, now it's not available. So we'll let Cognos come back up. So it's a number of things that are happening. If this were a full AZ outage, RDS would have to fail over. That'd be one of the big ones. That takes about a minute. That's what the AWS documentation says, and my personal testing found to be true. The content manager has to fail over. It's a Cognos specific piece, but that has to, the secondary has to register, has to detect that the primary is down and has to re-register itself. Then the ALB also has to register that there are instances that are no longer available, that are no longer healthy, and then stop routing traffic to those bad instances. In this case, it's the gateway 1 instance. So those are down. So like we said, while Cognos works to get back up, you can see all those instances are stopped. We'll go through a couple of other architectural examples of multi-AZ, and then we'll bounce back when Cognos should be back up and running. So we'll start with the simplest, 1AZ. So you can deploy in a single AZ. Like I said, I think it'd be a great disservice because you're limiting yourself. You're limiting the amount of failover. You wouldn't be quite as highly available that you would be if you were to split this across multiple AZs. But this is what it would look like if you did a simple AZ. And the ALB and RDS can be deployed in a single AZ architecture as well. You'd be losing out on a lot of functionality with that. And so for 2AZ, like the architecture we just saw, it would look like this. So see at the top we have AZA, bottom AZB. The ALBs do span across availability zones, so you can configure that to be in however many AZs that you wish to deploy Cognos. And so that's where the first piece comes in. Should that go down, the ALB is by default going to be deployed in more than one AZ. And then you have your Cognos tier components. So like we saw within the configuration, those instances are going to be deployed either in AZA or AZB. And then RDS as well, we mentioned. That can be in a multi-AZ format as well. In this case, our primary master database is in AZA, and then we have our standby sitting in B. So what we just simulated and what this looks like, so let's say we lose AZA, kapow, that's gone. That failover starts to happen. So I mentioned before, first thing we're going to have is health checks in the load balancer. It's going to register that it no longer has a healthy resource. In this case, it'd be gateway 1, and it'll stop routing traffic to it. Next, obviously, content manager we mentioned. Standby is going to have to register itself as the primary once it detects the primary is no longer active. And then RDS, you get a minute, just over a minute for RDS to fail over, for it to first detect that the master is no longer available, and then for the DNS failover to occur and to point to the standby instance. But standby instance then to start accepting start accepting write requests and become the master. And you don't need to constrain yourself to just 2 AZs. You can do 3, you can do more. You can do a lot of blends. So in this case, this is a little different. Instead of, before we had single purpose instances facilitating either gateways or dispatchers. In this case, we have gateways, dispatchers, and content managers all on the same instance. So, if you're wanting to cut costs, reduce the number of instances you're running, this could be an approach as well. The key thing to think about and to take into account when you're going multi-AZ is that whatever kind of architecture you take like this, whether it's all the components installed on a single box or individual purpose servers, everything needs to be mirrored. If you have a gateway, dispatcher, and content manager in AZA, you have to have a gateway, content manager, dispatcher in AZB and AZC, and so on and so on. If you miss the dispatcher or miss the content manager, you wouldn't truly be multi-AZ, because if that primary AZ were to go down and you look to fail over, you'd be missing a key application component, which then obviously would be an issue. Cognos wouldn't work. So you have to mirror across all the AZs that you're deployed into. Okay. So before we jump back into EC2 instance types, let's jump back over to Cognos. And let's see, should be back up and running. Oh, there we are. Yeah, just a few minutes. Like I said, that simulated losing an entire data center, essentially. Lost an entire data center, and just walking through a couple architectural slides without having to lift a finger, Cognos is back up and available. So we can even log back in. And there we are. So yeah, multi-AZ, very important to understand and more important to implement, especially if you have multiple application components. Highly recommend doing it in a multi-AZ fashion to have this kind of availability and resiliency to failure at the network or infrastructure layer. Okay, so the final section we want to look at is EC2 instance types and sizes. So it's probably something most people are going to be familiar with, but if you're not, this is going to be something, the server size of the EC2 instances that you'd be provisioning. For migrations, I always like to caution, never assume your existing sizing will translate perfectly. It's a good, use it as a guide rail, use it as a starting point for sure, but it may not be perfect. It may not be the exact hardware. You just may see different performance than you've been used to. What you can also do, the IBM has their t-shirt sizing and sizing guides. Probably a good opportunity to run through that again. Maybe your usage pattern has changed, and this would be a good opportunity to take a look at that and try to right size again and see if the existing assumptions still fit. But what you can do is, especially if this is a first time migration, maybe go with the existing sizes that you have. Just go with whatever you feel is close or approximate to what you would expect. Let it run for a few months. This is the benefit of the cloud. You mentioned before, these are not fixed resources. See what works. Let it run. You can use tools like CloudWatch, which allows you to monitor EC2 utilization and health. You can see, are you overutilized on CPU, underutilized, same with memory. And you can then scale up and down accordingly. That would be the best way I would recommend doing it. See what works. From there, you can then play with the sizes and types. And we're going to look at some of the types and sizes right now. So, here just a quick snapshot. If you've ever tried to spin up a EC2 instance and gone through, you can see the huge list of types. Be a little intimidating, but understanding just a few key elements makes it less so. For the first, just to break down some of this in the middle column there, for an example, there's the top, the R4.16 extra large. So R is going to be the class, and what we're going to look in a minute is the different classes that are probably most applicable to Cognos. 4 is going to be the generation. So there, that's an R4, then you have an R5. So the generation of that class. And then after the dot, it's going to be the size. So you see the dot 16 extra large, dot extra large. Then you see next to it is going to be the CPU count and then the memory count for that instance type. So again, that's where you can jump in and quickly see, okay, for Cognos, 4 core, 16 gig, 8 and 32, etc. You can look to expand that either way. But the class, that letter is going to be key. And we're going to look at a few different class options, like I said, to see what might work best. So the first one is the T class. This is a general purpose class. It's defined as a burstable class, burstable performance. What does that mean? It works a little different than other ones in that you build up CPU credits over time, and then when you have a burst of performance needs, you need to call on the CPU to do a task. Those credits are then spent. Once you spend them, you need to rebuild them to get the expected throughput of that CPU. So you can see that may not sound good, definitely not good potentially for production. You want a consistent throughput for production, but for dev and sandbox, that would be applicable. That would be probably acceptable. Internally, we typically use T class because it's not. We don't have high performance need. We don't have a lot of people hitting it constantly. It's more than acceptable. And the balance of the benefit is cost savings because it's not a guaranteed throughput. They are one of the least expensive options comparing with some of the other ones that we'll look at. So another good use case for working in a lower environment like a sandbox or a dev. Then we have M class. So this is another general purpose, and it's just a balanced class type. You're not going to have the fastest CPU. You're going to have good CPU. You're not going to have a lot of memory or the fastest, but you're going to have good memory. Just balanced. Going to be acceptable for most use cases. If you're starting out, again, and unsure, probably the one to go with until you get a feel for if you need more memory, faster CPU, etc. This would be a fantastic starting point until you get a feel for that. Then the C class, it's compute optimized, easy to remember, C compute. And use cases for this, anything with batch processing, HPC, high performance computing, machine learning. For Cognos, it may come into play if you're running in a situation where you're constantly maxing out your CPU, maybe you're in M class and you keep bumping it up, and it still seems like you're having CPU performance related issues. Try with the C class because you are going to get more high performant processors. The processor types won't be the same between all of these. Those will vary as well. So that's another key consideration. So it may be something where you just need a better performing CPU chip. This would be a good one to test out for those kind of use cases. And then finally, we have R class. This is a memory optimized class. So you're going to have higher volumes of memory, faster memory. And because of that, it's good for obviously in-memory workloads. So also anyone running like TM1 or plain analytics as well, this would be the class type to go with. Now that's all maybe all good, but okay, now which one to be used for Cognos? Well, there's no hard rule, but as a general rule, I would recommend starting with an R class. Why? Well, memory, in my experience, is always a premium within Cognos environments, and especially with the advent of 11. Think of all the features that have been crammed into in-memory, right? You have data sets, dashboards, explorations. More and more is getting pushed into memory. More and more instances I'm seeing that if there are performance issues within Cognos, the answer is typically increase the memory. So as far as dollars spent, you're going to get more memory for your dollar going with an R class, and more likely will take advantage of those resources, that memory resource, than you would one of the other classes that may be more compute heavy. But at the end of the day, use what works for your environment. If you don't have users that are heavy into dashboarding or explorations, and you're not using data sets, and you don't have a big memory footprint on your Cognos servers, you don't need to go with an R. Maybe you can go with an M. So again, have that 3-month window. Deploy with a class type that you may have a gut feeling of what works for you, and then go back and look at CloudWatch logs, see what's actually working, see how you're utilized, and then tune and tweak and resize those instances from there. So as a wrap up, just want to reiterate, that if you're just starting on that cloud journey, just remember the core architecture doesn't change. How you think about best practices when deploying Cognos, how you think about configuring that environment, that will not change. But there are new services and technologies and techniques that you can use when deploying or wrapping around that familiar architecture to make it more resilient, make it easier to maintain than you had previously had access to with an on-prem deployment. And really want to stress this, use them. Don't be intimidated by them. Deploy Cognos, like I said, maybe just a rehost, get into the cloud, and then start to grow, start to learn from there. But definitely take advantage of them. I mentioned before, but make the investment in the cloud worthwhile. Don't just think of it as just a new data center. Take advantage of the services and infrastructure that is available on the cloud so you can maximize that investment and, again, make your life easier. That's the goal here. And then take time finding that right EC2 instance types. Oftentimes, especially with on-prem, sit down for a net new deployment or an upgrade of Cognos, and it's okay. Well, what size? How big of servers do we need? Because that is going to be a fixed cost. It's something we're going to need to lock in right away, and it's not always clear. Having tried to size environments before, it's part art, part science, right? But you have tools now capable of quantifying that, so you can more precisely pick a size and a type that will fit your company, your environment more precisely. So take advantage then and take the time. It's not something that needs to be locked in stone out of the gate, but hopefully after a few months you'll have a better feel for what that sizing looks like. And with that, we will open up to questions. Thank you.
All right, thanks, Chris. And let's now go to some questions. First one, how do I manage aliases when upgrading? Oh, got you muted here, Chris.
Yeah, no, that's a great question. Yeah. That is, it is a little tricky. So one of the best ways I've seen is to leverage a lower environment ALB, like a dev ALB, hook it up to the dev ALB. You'll have your prod alias that presumably then you wouldn't use in a dev environment, so that during those cutovers, you can always cycle that same alias between the two, and you won't have any conflict. So yeah, just plan out those environment aliases and just make sure there aren't any that are being duplicated between those two, and then you can just bounce those back and forth accordingly.
Great. So you have to use an ALB with Cognos running on AWS?
Nope, absolutely not. There's no hard or fast requirement too. We always recommend doing it just for the reason that we outlined, but we've known many clients that have deployed without an ALB and it's worked just fine.
Okay, and then what are some ways you can monitor your ALB?
Sure. So the load balancer itself has a number of health checks built in. You can have health checks for the aliases or target groups that you've configured. You can do further health checks as well. We mentioned CloudWatch is there as being able to monitor EC2 instances. You can also use it to monitor the ALB, also the health of the application. There have been patterns that we've set up to leverage AWS Lambda. If you're not familiar with that, it's a way to execute code serverlessly. So, something like using CloudWatch to trigger a Lambda every minute, 5 minutes, to check to make sure that the gateway and dispatcher URLs are up and available. If any of those come back with a basically anything that is like a 200 response, it would then send an email out and alert the team.
Great. Here's another. Would I need to license all licensable Cognos components in all environments that are being referenced by the ALB, or do I need to license the one that is actively used?
So licensing is a good question. The trick with licensing is it's the same as on-prem. So the only thing that ALB changes is just the entry point to those environments. However, you are licensed within those individual environments won't change. The only thing that changes is how users would be entering that environment. Instead of directly through a Cognos gateway, it'd be through an ALB. But same licensing applies, whether it's PVU, per user, et cetera. That'll all stay the same.
All right, great. How many AZs are recommended for multi-AZ?
I would say, obviously, minimum 2. 3 would be probably the sweet spot. You can go more. At that point, though, it's going to be a lot of infrastructure to manage. And if you're looking to simply increase your resiliency beyond that point, you may want to start maybe looking at a DR plan with another region.
Makes sense. Does IBM support Cognos with RDS?
IBM does not officially support RDS because it is not a database engine. IBM, if you look at their documentation, and I've chatted with support on this, they support database engines. So SQL Server, Oracle, DB2. They don't support database platforms because that's just how it runs. Whether it's on a data center server or RDS, the platform is irrelevant to them. It's the engine type. So if you're running on RDS and troubleshooting with support gets you to a point where they say it's something with the infrastructure of the database, they'll direct you to that vendor, which in this case would be Microsoft or Oracle or AWS. Just like you would be on-prem and say, you need to contact your data center support staff to figure that out.
Okay. What are the advantages of Cognos on AWS over QuickSight?
With Cognos, it would probably depend on where you are. I mean, obviously, if you're a legacy Cognos user, you probably have a lot of content already built. So that would be a key area. There are some advantages around more enhanced data modeling, being able to blend data directly in a tool like Cognos. If you have anything, like any kind of cube requirements like Transformer or TM1, being able to do that natively in Cognos as well. So there are definitely some advantages, especially on the data side of how to blend certain data, combine it, and structure it so you can present it to users in a format that they need.
Yeah, and I don't think QuickSight really covers sort of enterprise reporting use cases, right? It's a little more like kind of like dashboarding, self-service dashboarding tool.
That's a good point. Yeah, it is. I would liken it more to dashboard versus reporting. So if you would have like standard finance reports that get sent to the board, or you have customer-facing reports that go out in PDF that have to be pixel perfect. I think QuickSight is getting there, but as of today, being able to have that burst capability, email capability, and repeatability with a lot of those reports that need to be very fine-tuned, that'd be another use case for Cognos.
Okay. I think we have one more here. Is there a best practice to controlling and monitoring AWS costs?
There are a number of best practices. AWS itself has a whole suite of tools that allow you to monitor usage. They have cost analyzers, budget reports. They have their own reporting dashboard within their cost analyzer that allows you to manage that.
Great. I think that covers all the questions. Chris, thanks so much for the great presentation, and thanks for fielding some questions here.
Yeah, absolutely. Thanks, everyone. I hope that everyone enjoyed it.
All right. Have a few announcements here before we finish up. So first of all, some upcoming sessions. 3:30 Eastern, which is next, and actually are the final sessions of Bacon 2021, we have an enablement session, hands-on with Amazon QuickSight. So I know someone just asked a question about QuickSight. You can find out more about QuickSight in that session. That's going to be presented by AWS. Then there's an execution session, creating custom visualizations in Cognos, presented by Rory from PMsquare. There's also a Genius Bar session on cloud migration at 3:30 Eastern time as well. So still time to get in on that, where you can get some one-on-one attention with one of our experts. And that's it. Thanks everyone for attending this session. Please enjoy the rest of the conference.